Elon Musk is intent on starting a colony on Mars, and his space exploration company SpaceX is developing and testing the spacecraft that will take the colonizers to the Red Planet. However, while many fans of the company and Musk have been disappointed by the delays in launching Starship, all that is about to change as SpaceX is finally ready to launch the spacecraft to orbit. But this is after upgrading the rocket. What new features has SpaceX added to the Starship, and what has been upgraded on the rocket? Join us as we dive into how SpaceX is finally launching the Starship to orbit in May 2022. Elon Musk believes planet Earth may suffer a cosmic catastrophe that would wipe out humanity completely. But the billionaire has a way out for us to survive, put some people on Mars to live permanently so that at least some of the human race continues. However, to create a community on Mars that can survive on its own, Musk plans to transport at least 1 million people. While it is debatable if Musk will find 1 million volunteers for his scheme, what is not debatable is the complexity of the operation. Mars is far, millions of miles away from the Earth, and no existing spacecraft could support humans on such a massive voyage. But that was before Musk conceived the Starship. It is a purpose-built space vehicle that will be equipped with life-sustaining components for the grueling and momentous voyage. However, the Starship will be used for other purposes, including traveling to the relatively near Moon and transporting people and cargo between places on the Earth. The Starship will also be used to put satellites in the Earth's orbit, and SpaceX has made some upgrades to the rocket just for this purpose, as you will see in this video. The Starship is a completely reusable spacecraft in upper and lower stages. This is a massive improvement over SpaceX's existing rockets. While this feature makes the Starship more complex to design and develop, the benefits of reduction in operating costs are totally worth it. The Starship can lift up to 150 tons of cargo to orbit thanks to the more than 30 Raptor rocket engines on the lowest stage, also known as the Super Heavy. SpaceX has upgraded the Starship's nose and domes, so you might observe some slight differences at the tip of the spacecraft. Actually, SpaceX has been working on a new and improved version of Starship's nose cone for at least a year by assembling pathfinders and prototypes of varying fidelity. But looking further down the rocket, you will see that there are hints of more recent changes. SpaceX is making these changes to simplify the assembly to make the Starship faster. Here is how SpaceX makes a Starship cone. The team starts by producing a series of thin stamped steel sheets. Once aligned on custom-built jigs, those sheets would be welded together to form a slightly conical ring. There are 5 rings, each narrower and more conical than the rest. The 5 sections then stacked one by one and welded together along their circumferences. In all, SpaceX will have to do 120 complicated vertical welds to get just the basic structure of the nose. There would be additional 5 welds along the circumference, which is even more complicated. But the upgraded design simplifies the process by increasing the size of the stamped sheets. Aside from modestly reducing the number of longitudinal sections needed to form the cone, SpaceX has also reduced the number of stacked sections from 5 to 2, slashing the total number of pieces of steel sheet needed by at least a factor of 2 or 3. These kinds of upgrades are a great sign of SpaceX's increasing confidence in the design of the Starship, as it is now simply optimizing the production or manufacturing process. As mentioned earlier, the Starship will be used to launch satellites to orbit. While SpaceX will launch for other companies and government agencies, it will also be its own customer, as it will use the Starship to build out its own Starlink satellite network in orbit. These satellites will expand SpaceX's Starlink satellite business to provide services globally. This is one of the reasons SpaceX takes the Starship's ability to launch satellites seriously. The company has now added a Starlink satellite dispenser to the Starship. Of course, there were speculations about what the module SpaceX was adding was before its purpose became clear. The device, which was installed inside the steel rings of the Starship's S-24's nose cone, will eventually be stacked on top of it. This component is almost nothing like any satellite deployment adapter we have seen, but SpaceX is a company that always tries new things. SpaceX had earlier dropped a cylinder measuring around 9 meters by 9 meters inside a part of the barrel-like section of the 5 steel rings. However, the cylinder looked rudimentary with no moving parts, making it hard to guess what the company was up to. but based on its apparent dimensions, the frame could likely extend anywhere from 10 to 15 meters up into Ship 24's nose cone before the diameter would get too narrow for it to continue. However, when the crew turned the nose barrel around, it revealed an unusual cutout similar to a giant mail slot. It became clear that Ship 24's nose had been fitted with a Starlink satellite deployment mechanism akin to a giant Pez dispenser. Instead of a large alligator-like payload bay, the Starship requires a tiny slot and an active or passive mechanical deployment mechanism. SpaceX will load the Starlink satellites one by one into the slot and somehow lift them inside the bay on the rail-like frame it has also installed. Eventually, that dispenser would be filled with a stack of an unknown number of Starlink satellites, likely larger Starlink V2 prototypes, but possibly today's smaller version 1.5 satellite variant. When the Starship gets to orbit, the stack of satellites would be ejected one by one through the payload slot. The satellites could be fed down to the slot with a tension mechanism or Starship's maneuvering thrusters, which will significantly reduce the dispenser's complexity. SpaceX has also completed second and third cryogenic proof tests after carrying out repairs to fix the damage suffered during the first round of testing. The test began almost immediately after SpaceX rolled the repaired Super Heavy booster back to the Orbital Launch Site (OLS) on May 6th. After a quick installation on the pad's stool-like launch mount and another day of systems checks and integration, Booster 7 began its first cryo-proof after its first repair on May 9th. It is noteworthy that SpaceX did not start small by validating the repaired plumbing and header tank with a series of smaller tests. The company instead jumped straight to a full cryogenic proof. It filled Booster 7 to the brim with about 3,000 tons or 6.6 million pounds of liquid nitrogen, or a combination of liquid nitrogen and liquid oxygen. With a large volume resulting from the height of 67 meters and width of 9 meters, it took about 2 hours to fill Super Heavy's tank fully. That was the equivalent of 1.5 Olympic swimming pools of cryogenic liquid. The liquid, kept at minus 320 degrees Fahrenheit or minus 196 degrees Celsius, rapidly cooled the booster's 4mm thick steel tanks to cryogenic temperatures. As expected, the cooled temperature froze moisture directly out of the humid air and covered almost all of Super Heavy's exterior with a layer of frost and ice. SpaceX began emptying the Booster 7 soon after the filling process was completed. Thanks to plenty of insulated plumbing and well-insulated ground storage tanks, SpaceX is able to recover nearly all of the liquid nitrogen and liquid oxygen used for cryo-proof testing. Otherwise, SpaceX would have to truck in more of the testing gases, a process that involves hundreds of semi-trucks and complex logistics to fill up the tank farm. This allowed SpaceX to carry out another cryogenic proof test on Booster 7 just 2 days later. Once again, Super Heavy was fully loaded with thousands of tons of liquid nitrogen and oxygen. However, this time SpaceX left the Super Heavy prototype topped off for a good hour before commencing detanking. However, after detanking the Super Heavy, SpaceX immediately refilled the liquid oxygen tank with a few hundred tons of either liquid nitrogen or liquid oxygen. As soon as the rocket's thrust section reached some degree of thermodynamic equilibrium, the crew remotely retracted and reconnected the orbital launch mount's Super Heavy umbilical. The launch mount umbilical, or quick disconnect, connects the Super Heavy to the pad's gas supplies, propellant storage, power, and communications. This test must have been a rough simulation of one scenario Starship could potentially face: aborting a launch post-ignition. In other words, SpaceX wants to see if an orbital Starship launch is aborted just before liftoff, but after quick disconnect retraction, could it quickly reconnect to the booster with zero human intervention? Let's hear what you think of the Starship launching to orbit in the comments section below.